Good day, ladies and gents. Hope you guys are having a fine and lovely day. Today we're going to go ahead and start Unit 1. Okay, so a couple awesome things about that. I have hot topics for you. This right here, this lovely page is everything you need to know for this unit. Feel free to add as much information to this as you want. There's also a back to that. So you do what works for you. But this is what makes sense to me. And if you want to add more stuff or just ignore a couple things, you just do what works for you. Hopefully that helps you out. Okay, so let's go ahead and go to the next thing. So we're on page 1. So we just had our hot topics. Now we're on page 1. We're just going to go through a couple of vocabulary words. So I'm going to zoom in as soon as I find the button. Set the button. That's the button. Okay, so here's the button. All right, so we have this symbol right here. See how there's two arrows on either end? That is line AB. So it's a line, and it has the infinite line that contains points A and B in it. So basically, what we're saying, and we're just going to add this information to the side here. So basically, we have a line going on forever and ever in either direction. It has point A in there, and there's point B, and there can be as many points along that as possible, as many points as it wants. So, but it has A and B on it, and it goes on forever and ever in either direction. Okay, this one, see how there's no arrows? This is called line segment AB. So it goes AB with no line above it, or it can have a line above it. So it either looks like this or it looks like this. So both ways are fine, as you can see, right? Okay, and then the line segment between A and B. So it starts at A, it ends at B. So we could look at like this, right there. Okay, another one is ray AB. Now, ray AB, so if I say ray AB, I start at A, I end at, I keep going through B. So it starts at A, it shoots through B, right there. So for another example, if I said ray BA, then I start at B and I shoot through A. And it doesn't always have to be in that direction. If I was doing my ray AB again, I could automatically go this way. I start at A, I go through B, but this time I'm going to the left. So that's also okay. And I'll zoom in because I know that's a little small for you guys. All right, sweet. Okay, perpendicular. Now, these two things are so important, because you're going to see this in this unit and next unit and 1,000 more times. It's parallel and perpendicular are super, super important. So let's put stars next to that. You might want to grab a highlighter and highlight that. You do what works for you. Okay, so those symbol right there. So perpendicular, look at the symbol. That means that these two lines intersect at 90-degree angles. And it doesn't have to be looking like that direction. It could be sideways like this. So notice it's not straight up and down anymore. It could be like this, or it could be sideways, whatever works for you. Okay, so if something doesn't look familiar to you in geometry, just rotate your paper, and then that might actually help out. So AB is perpendicular to CD. So those two lines intersect and they make a 90-degree angle. And then parallel means that they never intersect. They go on forever and ever in either direction, never touching. So those two lines parallel. So it goes on forever and ever without touching. No touchy. No touchy. So they never, never, never touch, no matter how forever they go, forever and ever and ever. Okay, so we're talking about parallel again. Let's zoom out a little bit. Okay, so you see those arrows right there? That means that these lines are parallel to each other. It's a second set. This right here, these three lines are all parallel to each other. So you see how they have a single arrow? That means that that's one set of lines that are parallel. And then these two arrows right here, that is a second set of lines that are parallel. So it doesn't mean that they're doubly long or anything. It just means that they are parallel to each other. So that's what those arrows mean. I'm just pointing those out right there. Okay, angle. So angle right here, that is an angle symbol. So like, let me just darken this line right here. So angle ABC is 45 degrees. So that means the angle formed by ABC, it makes that. So what that looks like, now you see that center letter? That's where the corner of the angle is. That right there is very important. So angle A, B, C. And notice that the center letter, that's where the angle was located. That's where you turned the corner. Okay, the right angle, that's this symbol right here. That's that symbol right there. That means a right angle. It means a 90-degree angle. Okay, this right here means congruent. So notice that there's the equal sign. And right here, that's a similar symbol. So the squiggly right there, that's the similar. So congruent means it has the same shape and the same size. So triangle ABC is congruent to DEF. We're going to see that in a few units from now. And there's that. And that's just the word congruent. Okay, congruent segments. So this right here, you see this notch. This is a notch. That's what we call. That little thing is a notch. Okay, so that notch means that this entire distance is equal to this entire distance. That's what that means. So what's that saying is, if I said, for instance, if I had this triangle right here, if I said that these two sides were equal, so if I knew that this was 10, this would automatically also be 10, for instance. So if I had a rectangle, let's say that this was a single notch and these were double notches. So if I knew that this was 3 and this is 4, then I would automatically also figure out, see how that's a double notch? This would also be 4 right there. And that's a single notch, so the single notch right here would also be 3. Okay, and so this was an example, and this was a totally different example. Okay, now here's the thing. Just because there are double notches doesn't mean it's doubly as long as the other one. So it's just a second set of things going on. Awesome. Okay, congruent angles. Okay, so it may not show up on your paper, but there's a single angle right here and here. So it's just a little curve right there. And that means that those two angles are congruent. So that means that angle A is congruent to angle B. They are congruent to each other. They are equal. And once again, we'll deal with that in the next unit. This little symbol is degrees. This symbol is, well, what shape is that? It's a triangle. And this symbol right here means similar, meaning it has the same shape, but a possibly different size. So it has to be a different size. Now, if it was congruent, it would have the equal side. So that means it would be the same size and shape if it had the equal sign underneath. But because it's just similar, it's the same shape, but not the same size. It would be a different size. So basically, I'm saying like this. Like this triangle and this triangle. They are, only helps if you can see it. These two are similar to each other. You just zoomed in, zoomed out. So that's what similar means. Zoom in, zoom out. And that's what it means to me. Okay. All right, so we're going to flip the page. We're going to go to page 2. All right, so we're going to page 2. All right, so I entitled this randomness, but it is super important and awesome. All right, so let's go over it, shall we? Okay, so on this one, all right, so these are the important things. You need to know that the name of this, right? So this is called line. Let's see if I can move this here. There you go, line AB. So it goes on forever and ever and ever. It has number of points. How many points are along that line? Let's think about it. So it's a line forever and ever and ever. And every time you have a line, you can just put as many beads on that as you want. So think of a necklace that's stretched out forever and ever and ever, and it can be going on forever, and you can put as many beads on that as you want. Okay, so that's infinite. So you can have A and B on there, but you can also have X and Y, like those can be points. You can have D in there. Okay, so you have an infinite amount of points, and there's no endpoints because there's arrows. That means it goes on forever and ever and ever. So line AB has an infinite amount of points and no endpoints. Very important. Okay, this one right here, this is called line segment AB or segment AB. Once again, you have an infinite amount of points. You have a starting point and an ending point, which is at A and B. And once again, you can have as many points along that as you want. Okay, once again, there are infinite amount of points and there are two endpoints at A and B. Because there's no arrows, it started at A, it ended at B. And finally, this right here is ray AB. So once again, we have an infinite amount of points because you start at A, you shoot through B, and you can put as many beads on that necklace as you want. And think of like the sun. So A is the sun, and there's the ray of sunshine. Okay, and how many endpoints do you have? Only the one. Sweet. All right, let's talk about this. Okay, so we are going to talk about angles. Okay, so this is very, very important. So think about it this way. This is angle BAC. So angle BAC, where think of B and C are the hands, and A is the center. Sorry, the corner. Okay, that's the corner. So you're trying to see how open you are. So they're your hands, and how open are your hands, and right here would be the corner. So how open do you have to open your hands? That's what you're trying to find out. So your hands are pointing towards B, and you're pointing towards C, and right here is where the angle is. All right. So notice that A is in the center, or it could be. So what can we call this, right? So I have a couple of things right here just to help you out in case you want to label stuff. All right. So what can we call this stuff, right? Okay. So good names. We can call this angle A because that's where the angle is. That's where it's located. We can also call this angle BAC. So BAC, where I went along here, I turned the corner and I came back. And I kept going, sorry. I turned the corner and I went going, and A is at the center right there. Okay, we can go backwards. CAB. That's another good one, where A is the center again, and you're pointing towards C, and you're pointing towards B. So you're at A, you're pointing towards B, you're pointing towards C. That's where your hands are located. Okay, we can also call it, so right here, we could also call this angle 2. We can also call that angle 2. Now, the bad names, so these are the bad ones, and we're going to talk about why they're bad. So a bad one is angle ABC. Now, the corner was supposed to be at A, and that's not the center, so that's why that's bad. B is not where the corner is. B is not the corner, so that's incorrect. B is not supposed to be where the corner is. Okay, another bad one. We cannot call this angle B because once again, B is not the corner. Okay, and angle C. We cannot call this angle C, so that's bad as well because C is not the corner. Okay, so all those were bad. So those were bad. We were not allowed to call it those. Okay. All right, let's look at another example here. Okay, so this problem right here. Okay, let's talk about the good names. So what are good names? So first of all, where's the corner of this? Where's the corner? What letter? Okay, you guys should have said X. So we can call this angle X. Now, we're at X and we're pointing towards Z, and we're pointing towards Y. So that's a good name. Or you could say the reverse version of that, which is YXZ. So YXZ, where X is the center again. Where you're pointing towards Y, you're pointing towards Z. Okay, we can also say if our hand was pointing this way again, but even longer than before, we could say WXZ, or we could say ZXW, the reverse version of that. Okay, so those are all good names. Those are all good names. Now let's talk about the bad names. What are the bad names? Okay, we cannot call this angle 72. We cannot call this 72 because that is a degree, not a name. See, 2 was the name. This is a degree. So this, so 72 is, that's a degree, not a name. That is a degree, not a name. That's why that's bad. Okay, what's another one? We cannot call this WYXZ. Well, for one, that's too many stuff going on right there. Because we're supposed to just have where the corner is and 2 hands. Right now we have we have too many letters. So that's too many letters. And then we have another bad one would be WYX. Well, X, so X would be supposed to be the center, but here's the problem here. We don't have 2 hands. We're only talking about the one hand. Only one hand. So we only have one hand going on right here. Sorry, let's try it again. Hand. So those right there, all those were bad. All those were bad. So you want your center, so you want your corner, so your center letter needs to be where your corner is, and the other 2 letters need to be pointing for one hand and then the other hand. It doesn't matter how far you shoot, just as long as you're pointing in both directions. Okay, and let's do another. Okay, so this one right here, I like this one. Okay, so this one, all the names for each of the angles. Okay, so angle 1. So here's angle 1. So angle 1 could be, we can do angle ABE, because the corner's at B. Let me zoom in a little bit here. Okay, we can call it that, or the reverse version of that, EBA. So those are both good, but can we call it angle B? No. Now, why can we not call it angle B? Because there's too many options. Too many options. So if I'm saying angle B, you don't know if I'm talking about angle 1. You don't know if I'm just talking about angle 4. You don't know if I'm talking about angle 3. There's too many possibilities, whereas this one only, when I said angle X, you knew automatically I was only talking about this one. So angle B is not okay. All right, let's try angle 2. Okay, so here's angle 2. We could say ABF, or the reverse version, FBA. All right. Okay, so let's see. Angle 3. Okay, so angle 3, we can say, so FBC, or the reverse version, CBF. And remember, we only need our center, right? Our center letter is our corner, and we just need the 2 hands. And there's actually 2 more. Instead of going to C, we could have gone to D. So we can go FBD, or the reverse version, DBF. All right. So I want you guys to try number 4. I'll give you guys a minute to try number 4. Everybody is trying angle 4 right there. Give you 1 minute. Go for it. Awesome. Okay, let's see what you guys got. For angle 4, let's see if you got the right answers. We got EBC is one of them, or the mirror image of that, CBE. And another one would be EBD, or the mirror image of that, DBE. All right, sweet. Now we got these extra boxes here. That's if you think of any other random information you think you need to know as time goes on. All right, excellent. Okay, let's go to number 3. All right, so we're on page 3, guys. We're on page 3. Okay, page 3. First of all, you guys need to remember that the whole point of this is to talk about points, lines, and planes. Those are the 3 fundamental things that you need to know about geometry. Points, lines, and planes. Super important. I cannot stress that enough. Points, lines, and planes. All right, so what is a point? Okay, a point is a location. A point is a location, like point A. Point is a location. It has no size and it has no shape. So it could be a dime or it could even be a quarter. Or it could be a state. Those are all locations. It could be your car. It could be a school, a point on a map, or a point on your paper. Okay, so that is a point. Always use uppercase letters when you're talking about a point. So for example, point A is what this one's called. Point A. All right, let's do another one. Okay, so this right here, we're going to add some extra points if I haven't already. So let's put a Z right here. And I'm going to put the letter A right over here. Just randomly. Okay. Okay, so this right here, this is a line. Okay, a line is made up of points. It just has a bunch of points along a line. Any 2 points can form a line. So any 2 points can form a line. So what am I talking about? So if I have these 2 dimes, those are 2 points. And no matter what I do, if I connect that, boom, there's my line from here to here. If I move them this way, well, there's my one line that goes through the 2. If I go like this, there's the one line that goes through the 2 points. Okay, so 2 points can form any line. So any 2 points form a line. Okay. Then a line has no width or length. Now, it's a line that goes on forever and ever and ever. Now, a line segment, we're talking about a line. So it has no width, so it can be as wide or thin as it wants to be, and it goes on forever and ever and ever in either direction. Okay, so we're going to name a line by any 2 points on the line, or a lowercase letter. Okay, so first of all, it's made up of points, right? So we only want to take points that are on that line. So we can call this line XZ, and we put arrows above it, right? Now it's a line. We're talking about a line, not a line segment, a line. So we have to put the arrows. Okay, we can call this x to y. We can call this, and remember, we can always use the mirror image of these, right? And we can say z to y, or the mirror image of each one, z to x, y to x, y to z. Okay, and there's one more. Now notice I didn't use A because A was not on, so A was not on the line, so we couldn't use that as our description. But we could also say this right here. We could say line N. We could say line N. Now, why is that? Why did I have to say line N? Why can't I say N with a line above it? This is at the, see how it's in cursive? It's at the edge of this. That's the actual name of the line. Actual name. That's the actual name of the line. Okay, collinear points. Points that lie on the same plane. All right, so that's important right there. So collinear, they coexist on the same line. They coexist on the same line. So X, Z, and Y are all collinear. A is not. Non-collinear points, points that do not lie on the same line. There must be at least 3 points. And basically, they have to make a triangle. So as long as they make a triangle, then they do not make a line. So if I'm talking about non-collinear, they make a triangle. So basically, X, A, and Z would be non-collinear because they make a triangle. So if you can make a triangle, then they are non-collinear. Okay, next, a plane. Okay, so okay, I'm gonna put an extra point on here, call that M, and I'm gonna shoot past that and make a line out of that. Okay, and I'm gonna zoom in so you can see it. Hopefully I already labeled that onto your actual picture before I make copies. Let's see, okay, a plane. A plane is a surface, okay, made up of points. Okay, and then any 3 points make up a plane, okay? But they have to make a triangle when they do it. So they have to be non-collinear. So any 3 points that make a triangle, okay, make up a plane. A plane extends infinitely in all directions. Name a plane by any 3 non-collinear points on the plane or an uppercase letter. All right, so what do we have here? We have, so remember, it needs to make a triangle, right? Okay, so we can say, now see this P right there? That's the actual name of the plane. Actual name, because notice it's not a point. So we can say plane P. That would be one possibility. Okay, but we want points, right? So 3 non-collinear points. Okay, so as long as they make a triangle, we're okay. So J, K, M. So J. So we would say plane J, K, M. That's one. We can say, and we would just keep saying plane, J, K, L. That's another one. We can say M, K, L. J, JLK. I think I already did that. See, okay, so I already did that one because it's any combination of those letters. So I was about to do JLK, but I already did that right here. So any combination of those 3 letters in any order still counts. Boom. Okay, I think I got them all, but we'll see. 1, 2, 3. Yeah, and then can JML be good? Is JML good? Is that? No, because they're all on the same line, so that's not good. Nope, because all those were collinear, so that one did not work. Okay, so coplanar. coplanar are points that all lie on the same plane, so all of those points are all on the same plane. Non-coplanar are points that do not lie on the same plane. So think of like a tissue box. I'll zoom out here. All right, so if you look at a tissue box, so that would be like this point right here and this point right here. Those are not on the same plane. But like if all three of those, 1, 2, now any 2 points could make that. So any 3 points could actually make a plane because you would just like cut through it. But at the moment it's kind of hard to make those all the same plane. You just need to make so any 3 points can actually make as long as they're not all in the same line, they would be planar. So think of you slicing through there. And if I lost you, you're totally okay. No worries. I just babbled a little bit. Okay, let's zoom back in here. All right, here we go. Okay, we're almost done, guys. Almost done. Okay, so okay, this one. Okay, so super important. This is super important right here. Right here. Okay, so 2 lines intersect to make a point. So basically, you know how you have points, lines, planes? Basically, it takes a step down. So, points, lines, and planes. Right? Okay, so 2 lines intersect to make a point. 2 planes intersect to make a line. So just giving you an idea there. Okay, so think about that. If you have 2 lines that intersect, they would meet at this point right here. That is a point. That is a location. Okay, and then 2 planes intersect. So planes intersecting, they would make a line. And in this case, what line did it make? See, that one made that. Okay, what line did they make? They made line K. So they create a line. All right, so think about a folder. So if you have a folder like this, zoom out again. All right, so if you have a folder, okay, so this plane and this plane, they intersect to make this line right there. So you can see the edge of that line right there. Okay, and then finally, lines that do not intersect and are not parallel are called skew. Okay, so we're going to look at our tissue box again. Okay, so if you look at your tissue box, so these 2 lines right here are parallel. So those 2 parts right there. Let's see if I can zoom out more. Okay, so this right here, these 2 right here, those are parallel. So we don't want that. We want it, so that would be a good example would be this line right here and this line right here. So I go on forever and ever and ever, and I never intersect my bottom hand. So right there. So those would be skew lines. Sweet. All right. Okay, so now it is time for practice. So it's time for the practice part. So we're going to step through this together, hopefully as a group. I want you guys to try those individually, and we'll get back to that. But I just want to point out a couple things like this right here. Okay, so with a diagram, provide the answers to this. So this right here, think of a straw going through the top of your thing. So like T is right here. So here's T, here's Q, and then we have N down here, and the actual straw is the entire line M, and this right here is your plane. So if you keep that in mind, give those a try. So try number 1, and then we'll see if you guys got those answers, and I'll circulate to help you guys out. All right, so pause the video and give each little chunk a try. Okay, so you guys should have paused the video, and then here are some answers to that. So hopefully you pause the video, and here are some of the answers. Okay, so those are the answers. I'll focus on that in a minute. And then finally, now it's your turn. Once again, you guys are going to do practice. So you're going to do the practice on the very next page, which is this right here. And once again, you guys should pause and try that. Or I can go ahead and just leave the answers up there for you. And here are the answers to that practice on page 5. Yep, page 5. And hopefully that helps you guys out. And when you guys are done with that, go ahead and do your home learning and turn that into your computer. Turn that into the computer when it's time for the home learning. But right now, you guys are working on the practice. And hopefully that helped you guys out. Have a great and wonderful day.